Good morning, boys and girls. We are on page 13. Make sure you're on the correct page. For the first question, it says right here, fill in the lesson or fill in the chart. The first one is done for you. So what they have is they set it up in a chart, and here we have the division expression they want you to have, the unit form, the improper fraction, the mixed numbers, and the standard algorithm. So for letter A, they basically set up everything for you as an example. So for problem or letter B, we're going to work on that one together. So what we have here is 1 and 2 fifths. First thing I'm going to do is I am going to change this into an improper fraction because I need to figure out what number am I dividing to fill in the rest of the categories. So this is the only one that they really give you. So 5 times 1 is equal to 5, and 5 plus 2 is equal to 7. So that means that 7 is going to be the number that goes at the top, and the bottom number is going to be 5. So we get 7 fifths. So that's what I'm writing in here as my improper fraction, because that's where it should have gone. Now, with this number right here, I can do the rest. I can do the unit form. So that means that I have 7 fifths divided by 5. 7 fifths divided by 5. What does that give me? Is what I'm trying to figure out. Or not actually 7 fifths. I think right here what they did was 12 thirds divided by 3. So they want you to multiply the two numbers together. So that's what I'm going to do. So we have 7 times 5, which is 35 fifths divided by 5 is equal to 7 fifths. Over here, what we're going to have is 7 divided by 5. And that means that I am dividing over here for my standard algorithm. How many times can 5 go into 7? One time. 7 minus 5 is equal to 2, and my denominator is 5. So I get 1 and 2 fifths. Now to check, because that's what they did over here, they checked, so that's what I'm going to do. I'm going to make sure I check my work. So we have, we're going to be multiplying 5 times this number right here times 1 and 2 fifths. So I'm multiplying 5 times 1 and 2 fifths. And remember, 1 and 2 fifths is the same. So that means that I'm going to write 1 and 2 fifths times 1 and 2 fifths, or I'm adding them. 1 and 2 fifths 5 times. So we have 1, 2, 3, 4, and 5. Okay, and I'm going to add all of my whole numbers. So what we have here is 1 plus 1 plus 1 plus 1 plus 1, which is equal to 5. And then we have 2, 4, 6, 8, 10. So we have 10 at the top and 5 on the bottom. So we have 5 plus 10 divided by 5 is equal to 2. So 5 plus 2 is equal to 7. So my final answer is 7, and that is correct because 7 is the number that we see here, we see here, we see here, and we see at the top here too. Now, we're going to move on to letter C. For letter C, what they want me to do is they give me 2 divided by 7. So I already have that. I'm going to solve for this first. So 2 goes into 7 3 times because 2 times 3 is equal to 6. 7 minus 6 is 1, so my remainder is 1, and my denominator is 2. So I get 3 and 1 half. And in order to check that, I'm multiplying 2 times 3 and 1 half. So I have 2 times 3 and 1 half. So I write 3 and 1 half plus 3 and 1 half. And what do I get when I add that together? We have 3 plus 3, which is equal to 6. And 1 half plus 1 half is 1 whole. So 6 plus 1 is equal to 7. Now, what would I put here as my mixed number? Well, we have it. We have 3 and 1 half. It would be my mixed number. Well, what would we put here as our improper fraction? 3 times 2 is equal to 6, and 6 plus 1 is equal to 7. So we have 7 halves. And 7 times 2 is equal to 14 halves. 14 halves divided by 2 halves is equal to 7 halves, and we have 7 divided by 2, which are the numbers I got here, 7 divided by 2. Remember that this bar is a fraction bar. It's considered a division bar. So 7 divided by 2 are the same. Now, moving on to letter D. We have 7 divided by 4. We could do it like this. We have 28 fourths divided by 4 fourths is equal to 7 fourths. 7 divided by 4. So if I were to change that into an improper fraction, I would solve that right here. 4 can go into 7 one time. 7 minus 4 is 3, so my remainder is 3, and my denominator is 4. So I get 1 and 3/4. Now to check it, what I'm going to do is multiply 4 times 1 and 3/4. So I'm going to write 1 and 3/4 plus 1 and 3/4 plus 1 and 3/4 plus 1 and 3/4. I'm going to add my whole numbers right here. 1, 2, 3, 4. So that is equal to 4. And then we have our numerator. 3 plus 3 plus 3 plus 3 is equal to 12. So I have 4 plus, what's 12 divided by 4? That is equal to 3. And 4 plus 3 is equal to 7. So my final answer is 7. Now I'm going to turn the page. And we're working on page 14, and I'm going to read the first question out loud for you to hear. So it says here, a coffee shop uses 4 liters of milk every day. If there are 15 liters of milk in the fridge, after how many days will more milk need to purchase? Explain how you know. To figure this out, I would divide 15 divided by 4. And that's how I set it up right here. 15 divided by 4. Because there are 15 liters of milk right here. And I'm trying to figure out how many liters I would divide it into days. So these would be considered days. So how many times can 4 go into 15? 3 times. 15 minus 12 is equal to 3. My remainder would be 3. And my denominator would be 4. So I get 3 and 3/4 as my final answer. And if I were to draw that out, this is what it would look like. I would have altogether 15 pieces, and I can circle 4 for each one, and the remainder would be 3, just like what we see here. Now, after 3 days, they will need to purchase more milk because at the point, they will only have 3 liters left. So on the 4th day, they don't have enough milk, so they would need to purchase more milk. Now, problem B. If only half as much milk is used each day, after how many days will more milk need to be purchased? So they said half the amount. So I divided 4 divided by 2. So I cut 4 into 2, and I got 2. So 4 divided by 2 is equal to 2. That's where I'm getting that 2 from, because it's saying half as much milk. So I'm going to divide 15 divided by 2. How many times can 2 go into 15? 7 times, because 2 times 7 is 14. 15 minus 14 is equal to 1. And my denominator is equal to 2. So I have 7 and 1/2 left. So they will need to purchase more milk after 7 days, because 7 is how many days they would have full days, and then they have a half. So by the 8th day, they need more milk already. Next problem. Polly buys 14 cupcakes for a party. The bakery puts them into boxes that hold 4 cupcakes each. How many boxes will be needed for Polly to bring all the cupcakes to the party? Explain how you know. So we have 4 divided by 14. And we have our 4 cupcakes because we know that each box can hold 4 cupcakes. And there are 14 cupcakes in all. So that's where I'm getting that number from. So we're dividing 14 divided by 4 and figuring out what is our answer. So how many times can 4 go into 14? We know that 4 times 3 is equal to 12. So we're going to use 4 times 3. 14 minus 12 is equal to 2. And our denominator is equal to 4. So we have 3 and 2/4. So that means that Polly will need 4 boxes because 3 boxes will be completely full, just like the number 3 we have here. But the last box will only have 2 cupcakes in it because only 2 can fit out of 4. Now for problem B. If the bakery completely fills as many boxes as possible, what fraction of the last box is empty? How many more cupcakes are needed to fill the box? So they're asking you here, what if how many more do I need if there's 2/4, right, of the last box that is full? So this is what the last box looks like. I'm going to draw you a visual to see it. So we have a cupcake right here, and we have a cupcake right here, okay? And looking at this, there are 2 empty spaces, 1, 2. Those are the empty spaces. What's already being filled are these 2 spaces right here. So that means that in the last box, they need to have 2 more cupcakes to fill this box, because right here, there's no cupcakes right there. So 2/4 or 1/2 of the last box will be empty. 2 more cupcakes are needed to fill the box. And that is all for today. Please let me know if you have any questions in class.